Okay, so this is chapter 11, simulations. And so we're going to start with a problem here. At a certain company, 25 people are applying for 3 positions. We have an unequal number of men and women. All 3 jobs go to the women. Some of the men kind of complain. They say, well, discrimination, what's going on here? They want to figure out the truth. Was it chance? Was it how did this happen here? Is this likely? How unlikely is this? And so oftentimes what we do in stats is we run a simulation to figure out how unlikely a scenario is, or how likely a scenario is. Sometimes maybe this is just, girls are better and so they got hired. But we don't know. We want to find out how, if it's just by chance, if the hiring practice was just, random. In other words. Now, of course, it's not random, doesn't mean equal. We've got more men than women. What are the chances that all 3 are women here? They get chosen here. So we're going to talk about a simulation. It's a way to kind of figure out in stats how unlikely a situation is to happen. And it's a lot cheaper than actually going to many different companies and trying to reimagine the situation. So, first thing we need to get this idea of a component. So component is the thing that is repeated in the study. So like in this case, the component would be that you are hiring. In this case, you are hiring a person. Is one component for a job here. So you're hiring the person. Sometimes your component could be, each time you roll the die, that represents some component that you're modeling there. Explain how you will model this. So what digits will represent? Really, 2 and 3 go together. In other words, I don't know where 2 ends and 3 begins here. These 2 ideas go together. We've got to just be very specific about how we build this. So we might say, okay, we're going to use numbers to represent this. Let's go back to it. We've got a total of 14 and 11. 14 plus 11. I've got 25 different things. Since that's a 2-digit number, 25 is, I'm probably going to use maybe 2 digits here. So let's try that. So we're going to say we're going to use 2-digit numbers to represent that. And by the way, in stats, when we say 2-digit numbers, we can still use single-digit numbers. Like 0 is considered 0, 0, or 1 is considered 0, 1. It's considered a 2-digit number there. So we're going to use 2-digit numbers starting at 0, 0, going all the way up to, we really don't need all the way up to 99, although that may be what our automatic number generator builds us. So what we need is we need to clarify. We need the first 14 of them to be men. So 0, 0 through 1, 3. Notice I didn't say 1, 4 because we're counting 0 as a starting point, not 1. So 1 through 13 would be 13. But 0 counts as a number there also. So this represents the men. So if you choose a number from 0 to 13, 2-digit number from 0 to 13, it's as if you have chosen a guy. And then 14 through, let's see, not 25 because we started counting at 0, so there's 25 total, so I'm going to go through 24. I think that should be 11 different women. There's 11 numbers represented there. So if I choose a 2-digit number from 14 to 24, that's as if I hired a woman. My component is hiring one of those things. Now, I say 2 and 3 go together. We have to be specific now. What do we do with the rest of the numbers? Will it be any non-assigned digits, right? Well, we are going to take 25 through 99, the rest of the 2-digit numbers, and we're going to ignore. So we're going to ignore those guys completely. So we're going to ignore those guys. We got that. Are repeats allowed? You can't hire the same person for 2 different positions, so we're going to say no repeats are allowed there. How many digits are we going to use? Well, 0, 0 to 99, so that's 100 different digits, but they're all, the big key is they're 2-digit numbers, so 0, 0 counts as a 2-digit there. When you stop, so you stop after how many components will we, how many, let's see, we will need to hire 3 people. So we're going to hire, after 3 people, we're going to look at our results. So we've got 3 people there. Okay. Now we're to our fourth step. State clearly what your response variable is. So remember, explanatory is our x. We know that. Response is the measured variable that we're measuring. What are we interested in? We are interested in how many guys, how many girls were hired. After the 3 hires are made, is it all girls, is it all guys? And really, we're most interested in, is it all girls? That's the result we're most interested in. So we are interested in if you hire a woman, and a woman, right? That's the one we're really going to count here, because we could have all different other combinations. We don't really care about those. We want to figure out how likely is it that literally 3 women were hired for these 3 positions. Is that likely? I don't know. We're going to have to see. Run several trials. So we're going to actually run some trials here. So you can do this different ways. I'm going to show you different ways to do it. One way would be use your calculator. And if you hit your menu key and your TI Inspire, there's a probability thing here. And one of them is random. And you can choose random integer. It's also on the T84. But random integer command works like this. You put the lower bound and the upper bound. In this case, you might say something like 0, 1. And you say, how many trials do you want? I'm just going to say 1 trial. So if I press enter, it generates a random number, 1. Let's say 1 is men and 0 is women. So in this case, there were 2 men, those are men, and that's 1 woman. So the first trial, is, was 2 men and a woman. Okay, let's try this again. 2 men and a woman. So second trial happens. And we say, okay, 2 men and a woman. Let's try it again. Oh, we almost had it. We have two ladies and a guy. So we have our third trial is we're getting closer. I really don't know what's going to happen here. So 2 guys and a girl. Fourth trial. We tried 4 trials here, and we still are not successful. Ah, we finally got one. Okay, so we got one to what we wanted. We wanted to get 3 women. Okay, let's try a few more here. That's 2 women. 6th trial got 2 women and a man. Ah, we got 3 men. So the 7th trial, we got 3 men. I know this takes a while, huh? It's not the most efficient method. Ah, we got another one. So the 8th trial, we got 3 women. We have 2 women and 1 man. Now let's do 1 more. Oh, almost. So close. So the 10th trial, we got 2 women and a man. So we only did 10 trials. It would be nice to do more trials. I'm just kind of getting tired of doing trials, and so I'm going to stop. So what you want to do now is kind of look at this and go, okay, collect and summarize the results of all the trials. Which summary statistic should we use? So let's summarize these. We only did 10 trials. We're going to summarize what we did. So we said, okay, 2 of the 10 trials, which is really what percent? That's like 20%. 20% of the time, 3 women were hired. Well, according to this, our simulation, which you could do a simulation and you may not get these same results. In fact, you probably won't. But there's about a 20% chance that 3 women were hired. Well, that might be a little bit unusual, but that's not That's not super unusual. It raises eyebrows. I mean, there definitely could be something funny going on here in the hiring practices. I wouldn't say that's impossible, but just looking at it, there's a 20% chance. So our conclusion might be maybe it's inconclusive, or maybe we can say something like, although it is a little bit unlikely, it's not highly unlikely that 3 women would be hired at the same time here. So that's kind of our conclusion we might be able to make given from our result of our simulation. Again, if you did a different simulation, you might get different results. That's the way simulations work. But it's a lot cheaper oftentimes than actually doing the component that you're modeling, and it's a lot faster as well. So even though you have to do some more trials, it might be helpful. So another common type of problem we might think about doing a simulation. So suppose a basketball player shoots 80%. That's pretty good, by the way. 70% is, your coach is going to be happy if you can shoot at least 70%. And some coaches might, say, hey, okay, 80% or better is good. Shooting over 90%, you're really good. Okay, so how many can you use random numbers to simulate a foul shot? Okay, so let's think about the component. What's the component? What's the repeated event? Shooting a free throw. Right? We're shooting many, many, many free throws. So the component that is repeated and modeled here will be shooting a free throw. A trial. What does a trial consist of? When you start a trial, when you stop a trial. I might say something like, I start the trial when I make a basket. I'm not going to start, counting a streak until I can make a shot. And then I'm going to stop the trial. So the trial will end when I miss a shot, right? Because I'm going to keep going until I, at some point, miss the shot. Response variable would be what we're measuring. Well, I really want to measure how long this takes, right? So how many makes in a row? How many times do I, make the shot in a row? In statistic, usually something like, well, after I take a bunch of simulations, a bunch of trials here, I'll probably find the mean or average and see like, do I hit 2 in a row, 3 in a row, 4 in a row, that kind of thing. So I'd set up my trial. You could do this, by using a random number table. So this is called a random number table. It's generated by your computer or calculator or whatever. And so again, we need to find what it is. So 80%. So I'm going to say 0, 0. 80% is a 2-digit number. So I'm going to say through 79 is a make. And 80 through 99, the rest of them are misses. So I'm just going to take these 2 at a time. There's no numbers to ignore, by the way. Repeats. I think repeats are allowed. I'm going to say repeats are allowed here. Those are the kinds of questions you're looking at. So let's take the first 2 digits, 69. So that is a make. That counts, right? 17 are the next 2 digits. That is a make. Even though these are kind of spread out, I'm going to count these 2 as the next 2 digits. 92. They just do that for organizational purposes, but they're still the next 2 numbers in a row. 92 is a miss. Right, that is no good. That is a, I don't know how I want to notate that. Let's use a different color. So that's a miss. Whoops. So we're going to call that an X there with a red X. Okay. So then we do these. 79. 79 works. That's good. Oh, by the way, we finished our first trial, isn't it? So you can say something like, trial 1, and you have 2 is the amount of trials. We had 2 makes in a row, and then we missed it. So result of trial 1 is 2 in a row. We're already on trial 2. Sorry about that. So we have a make. So we started trial 2. 82 is a, that's a miss. Therefore, trial 2 is only 1 in a row. This is not looking promising. And you keep going like this, and that's how you use a random number table to do that.